Hello everyone. So today we are going to talk about loop analysis, and this is another method that we have for solving more complicated circuits. Before we did superposition, so now this is the second method, loop analysis, and by the end of this session you should be able to solve circuits with multiple sources using this method. So loop analysis or mesh analysis uses Kirchhoff's voltage law. And using this law, we develop a system of equations defining the system, and we could solve this system of equations simultaneously using matrix techniques to get the loop currents. So if you remember, Kirchhoff's voltage law states that the sum of voltages in a closed loop is equal to 0. And the basic procedure that we're going to go through is simply that we're going to define a current loop for each closed loop in the system. Now when we come to the example, you'll actually see what this means. It'll be a little bit difficult to conceptualize at this point. Then we're going to draw the arrows for the voltage drops across each loop, and then we're simply going to write a KVL equation for each one of these loops. And it's important that all the components in the circuit are covered. So let's start with a simple example. So we have this system here. We have our 10 volt source or 12 volt source and 3 5 ohm resistors. This is the same example we had for the superposition, so we should get the same results. So the first thing I do is I'm defining two loops. So this is one loop here, I1, and this is the other loop, I2. Now I could draw these arrows in any direction, clockwise or anti-clockwise. It doesn't matter. As long as you follow the procedure, you should get the correct results. So the next thing we're going to do is draw in the voltage arrows. So for the 10 volts, we know the voltage across the voltage source is defined. So this is the negative and this is the positive, so the arrow goes this way. Similarly for the 12 volts, the arrow goes this way from negative to positive. For the passive components now, to draw the arrows, we need to look at the current directions. So what we have to do is look at the direction of the current, and the voltage goes in the opposite direction, because remember, the current flows from high potential to low potential, and the voltage arrow points from low potential to high potential. So in this case, we have the current I1 going in this direction clockwise, so the voltage across this 5 ohm resistor will be to the left. And then for this center resistor here, it will be upward. And similarly for these resistors, the current is going this way, so the voltage arrow is going to go in the opposite direction, and the same for the center resistor. Now we have to start writing our equations. So what I do is, for each loop I'm going to write a loop equation. So let's take the I1 loop first. I1 loop. And I'm going to start at any point in the loop. So let's start here. And I'm going to go around the loop and come back to this point. So first, if I look at this point, I'll see the voltage arrow going upward. So it means the voltage is going up from this point to this point. So from this point, I add 10 volts. Then I have the voltage arrow now is going in the opposite direction, so I have to minus. So I minus 5 multiplied by I1, which is the voltage across this 5 ohm resistor. And then, so I went from this point to this point with the 10 volts, then I came to this point with the 5 I1. Now I have to come back down to this point. So to get to this point now, it is this resistor, so I'm going against the resistor again now, so minus 5, which is the value of the resistor, and the current through the resistor this time is a combination of I1 and I2. Both those currents are flowing through, so I1 plus I2, and now I'm back at the starting point here, so that should be equal to 0. And then I write my I2 loop, and I do the same thing. I pick a point, so I'm going to start here, and I'm going to go in this direction. So I'm going to add 12 volts. Then from here to here it's going to be negative. So because I'll be going from higher potential to lower potential, minus 5I2. And then again from here, higher potential to lower potential, minus 5I2 plus I1 is equal to 0. And now I have my two equations with two unknowns that I could solve simultaneously, and I should get I1 is 0.533 amps and I2 0.933 amps. Now I could have gone the other way as well. I could have started at this point, and instead of going this way, I could have gone the other way. I could go this way. And then that would mean I would have, going in this direction, I would have positive here, 5 I1 plus I2 plus 5 I1 plus, let me just make this one a little bit clearer, plus, now I'm going from the positive of the voltage source to the negative, so it will make it negative 10. And that will be equal to 0. So you can see that this and this is the same thing. It would be equivalent to taking all the terms and putting them on the other side of the equation. And that is basically how we solve the system using loop analysis. Good. So what you could do now is you could try this example that we have here. I've simply replaced the 12 volt source with a 2 amp current source. So you could try this example and see what you get. So go ahead and pause the video and try the example, and then we'll come back and do it. Okay, so if you're finished with that, again we're going to go through the same procedure. So first I'm going to define my current loops. So I'm going to do one loop this way, and I'm going to call that IA, and my other loop I'm going to do it this way and call it IB. Now I used IA and IB instead of I1, I2 and I3 simply because I have I1, I2 and I3 here already. So I didn't say I1 and I2 again. That would confuse which currents are which. So then I have to draw the voltage arrows. So again, for the voltage source, it doesn't matter what direction the current is going, the voltage always goes from negative to positive. For the 5 ohm resistor, again opposite direction from the current, 5 ohm resistor, opposite direction from the current. And I have my 2 amp source here. Since it is a current source, I don't know what the voltage is across it, so I could define it in any way I want. I'm just going to define it in this way and call that VCS. So I have all my elements defined now, and I have to start writing my equations. Now I'm going to do IB first because you'll see that IB is very simple. So if I start with the IB loop, I can see right away that the current IB, remember the current IB flows like this. So since IB is the only current loop that goes through this current source and the value of the current source is 2 amps, I could say immediately that IB is equal to 2 amps. So I don't need to solve for IB. It is defined by the current loop. And then IA, I could write my loop in the normal way. So I start at some point. I'm going to start at this point here, and then I'm going to go around. Let me go around in this direction. So I'm going to go around in the anti-clockwise direction. So first, starting through the 5 ohm resistor, it will be 5 IA plus IB plus 5 IA plus, or in this case, sorry, minus, because I'm going, so the first term took me from this point to this point. That is the 5IA plus IB. Then the 5IA, again going up through 5IA. And now I'm at this point and I'm going down. So that will be minus 10 volts. And that brings me back to the same point. So that is equal to 0. And I know here now that IB is 2. So I could substitute IB as 2 and I will get 5IA plus 2 plus 5IA minus 10 is equal to 0. And that should give me IA is equal to 0 amps. And if IA is 0 amps and IB is 2 amps, then I could solve for I1, I2, and I3 because I know I1 is equal to IA, so I1 is equal to 0. I3 is equal to minus IB because they're going in opposite directions, so it is minus 2 amps. And I2 is the current down here, which in this case, if we look at the nodal equation here, it will be I1 minus I2 minus I3 is equal to 0. So I2 is equal to I1 minus I3, which is 2 amps. So hopefully you would have gotten this as your answer. I1 0, I2 2 amps, and I3 minus 2 amps. So let's look at another question now. It's the same problem except I've shifted the 2 amp source to the middle. So if we draw the current arrows in to begin with, so I've taken now I1 and I2. This time I've put both of them in the clockwise direction. So if I draw them like this, what you'll notice is that this 2 amp source is shared, is a combination of both currents. So the 2 amp source here is actually I2, which is in the same direction, minus I1. So we can't explicitly state what the value of either source is, either loop current is. And at the same time, we don't have a value of resistance or anything here to get the voltage drop. But we're going to go ahead and try it anyway, and you'll see how we come up with a concept that we call a super loop. So which is a loop that integrates another loop into it. So to begin with, what we're going to do is we're going to write the loop drawing the voltage arrows first. So as usual, we start off with the sources. So the voltage source from negative to positive, and then we go with the other passive components in the opposite direction to the currents. So this time the current is going this way, so the voltage drop has to go the other way. And we have here VA. This is in the correct direction already. The only thing we don't have is this voltage drop across this 2 amp source here. Since it is a current source, I don't know what the direction is, so I could specify it in any direction. So I'm just going to specify it in this way, VCS for V current source. And now I'm going to start writing my equations. So first I have the I1 loop, and I'm going to start at this point and go around in the clockwise direction. So I have 10 volts from here to this point. Then from here to here I'm dropping, so it's minus 5 I1, and then I'm going from here to this point, which is minus VCS, and that is equal to 0. And then I have the I2 loop, And here I'm going to start at this point and I'm going to go in the anti-clockwise direction, and again you could go in any direction. So I'm going to go in the anti-clockwise direction and I get 5i2 plus 5i2 minus VCS is equal to 0. So I have here now 1, 2, 3 unknowns, but only 2 equations. So I need to find another equation. And to do that, I'm going to look at the 2 amp source and the relationship with that and the 2 loop currents. So for the 2 amp source, I could see that this 2 amps is a combination of I2, which is going in this direction. So I2 and I1, which is going in the opposite direction. So it's minus I1 is equal to 2 amps. And now I have 3 equations with 3 unknowns that I could solve. And that will give me that is the full set of equations that I need. Now why do we call it a super loop? If we look at this VCS, I'm solving for loop currents, but this is a voltage. So if I wanted to write it only in terms of the loop currents, I didn't have to use this this VCS. Because to go from this point to this point, I could go through here or I could go through here. So if I'm taking my I1 loop, and let's do it again. So I'm going to take my I1 loop and I'm going to go from this point to this point, 10 volts, just leave it as 10. And then from this point to this point, minus 5i1. And now I want to go from this point to this point. But I don't know the voltage across here. It is not defined in terms of loop currents. So to write it defined by loop currents, I could go around this way. So I'll go from this point to this point, and that is minus 5i2. And then this point to this point, minus 5i2. And that is, of course, the same point here. So all of that is equal to 0. And I get one equation with loop currents only. But it involved spanning 2 loops, so we call it a super loop. Now, if I simply combined my 2 equations here, I would get the same thing. If I say the I1 loop minus the I2 loop, it would get rid of this, and it would give me 10 minus 5i1, and then of course minus 5i2 minus 5i2 is equal to 0. So you could do it in either way, you'll get the same result. So you could go ahead and solve this and post your solutions, your answers on the forum, and if you have any problems you could post those as well. But once you have these 2 equations, this equation and I2 minus I1 is equal to 2, you just solve those simultaneously, which I don't think should cause you any problems, and that would give you the result. So to summarize, today we covered solving circuits using loop analysis, and this will work for multiple sources, voltage sources, current sources, and also we've looked at using super nodes to solve the circuits. So you can look at the supplementary notes for more examples where we'll cover things like dependent sources as well. Next time we'll be looking at solving circuits, same types of circuits using nodal analysis.